Number one, at a college, the students choose exactly one of tennis, hockey, or netball to play. The table shows the numbers of students in year one and year two at the college playing each of the sports. This is a table. One student is chosen at random from the 120 students. If an X and N are defined as follows. X the students is in year one and the students plays netball. Find the probability X given N. Right, so we use the conditional probability formula X given N. The formula is the probability X intersection N over probability N. Probability X intersection N is the probability the students is in year one and as well plays netball. So it is 12 over 120. You can check on the information. And probability N is the probability the students only play netball. So this is 40 over 120. So it is 12 over 40. And if you calculate this is 0.3. B, find the probability N given X. The probability N given X equal the probability N intersection X over the probability X. Same with this one. The probability N intersection X is the probability the students in year one and also plays netball, and it is 12 over 120. Over probability X is the probability students in year one. It is 50 over 120. It becomes 12 over 50, and if you calculate it is 0.24. Next question, C. Determine whether or not X and N are independent events. Two events X and N are independent if the probability X intersection N equal probability X times probability N. This conditions if X and if event X and event N are independent one another. Now let's calculate both sides and compare. We are going to calculate uh, probability X intersection N, after that probability X multiply probability N. First, the probability X intersection N. It is 12 over 120. So 1 over 10, 0.1. And the probability X multiply probability N, 50 over 120 times 40 over 120. So it is 2000 over 14,400. And if you calculate, the result is 0.1388, round off, 0.1389. So if you compare this result, this one 0.1 and this one 0.1389. So we can state that the X intersection N not equal the probability X times probability N. So it means the events, event X and N are not independent. Okay, because the result is different. One of the students who plays netball takes 8 shots at goal on its shot, the probability that she will succeed is 0.15, independently of all other shots. Find the probability that she succeeds on fewer than 3 of the shots. Okay. This is a binomial probability problem. Binomial probability problem. So like this, the probability x less than 3, based on this information, fewer than 3, it is probability x equals 0 plus the probability x equal 1 plus the probability x equal 2. Using the binomial formula, the probability x equal k equal the combination n k times speed power k 1 minus speed power n minus k. So it means the probability x equal 0, we're going to find this probability. This is the combination a 0, 0.15 power 1 times 1 minus 0.15 is 0.85 power 7 because 8 minus 1. And if you calculate, the result is 0.2725. Next, the probability x equal 1. This probability is a combination A1 of 0.15. This is power 0. Power 0 is 1 power 1. Power, this is supposed to be power 8 because 8 minus 0, and this is power 7 because 8 minus 1. And if you calculate 0.3847, and after that, x2, the combinations 8, 0.15 squared, 0.85 power 6, and the result 0.2376. Let's compute the probability x less than 3 equals 0.2725, 0.3847, 0.2376. And if you compute, the result is 0.8948. So number 2, find the number of different arrangements of the 9 letters in the word algebraic. Right. If you look this word algebraic, there are 2 letters of A. So number of different arrangements, number of different arrangement equal 9 factorial over 2 factorial. From 9 words and 9 letters and then 2A. Okay, so it's going to be, if you calculate, this is 362,880 divided by 2, and the result is 180,440. So on. Next, B. Find the number of different arrangements of the 9 letters in the word algebraic in which there are no more than 2 letters between the 2 A's. Okay, 2 A's, it means double A. Right. Firstly, you need to find the total number of valid positions for the 2 A's. You want to count arrangement where the 2 A's are separated by first the zero letters, the zero or without letters. Okay, without letters. So this is adjacent. It means A. Okay, and after that, one letter. Okay, one letter, such as A. One letter between A and A. Okay, and after that, two letters. Two letters like A and two different letters. Okay, right. Uh, Now let's go case by case. How many letters are between the two A's? Let's go find. I'm gonna start with the case one. The case one is this one, zero letters or without letters. Without letters between A and A. Uh, like the first letter and the second letter, the second letter and the third letter, so on. If you continue to find, there are eight ways. So there are eight ways. Eight ways placement. I mean, eight ways placement. Okay. And the remaining seven letters like L, G, E, B, R, I, and C, it can be arranged. It can be arranged, become 7 factorials, 5040 ways. So case one, contributions of case one. So case one contributes 8 times 7 factorials equal 40,320. Second case or case two. Actually, case two is one letter. One letter. One letter between A and A, such as first letter and the third letter, second letter and the fourth letter, so on until the seventh letter and the ninth letter. Okay. So the second case, there are, if you find this condition, the placement, so there are 7 ways placement. Okay, so 7 ways placement, so it means 7 factorials equal 5040 ways. So the case 2 contributes, uh, case 2 contributes 7 times 7 factorial. Calculate, the result is 30,280. And the third case, 2 letters between between A and A, such as like this, one, the first and the fourth letter, and the second letters and the fifth letters, so on until the sixth letters and the ninth letter. So totally in case 3, there are 6 ways placement. Okay. So it means the case 3 contribution, the case 3 contributes 6 times 7 factorial, 5,040, 30,240. So total 3 cases, 40,320 plus 35,280 plus 30,240 equal 105,840. That's the result. Number 3, a fair coin and ordinary fair 6-sided dice, okay, coin and dice, are thrown at the same time. The random variable x is defined as follows. If the coin shows a tail, x is twice the score on the dice. If the coin shows a head, x is the score on the dice if the score is even and x is 0 otherwise. Draw up the probability distribution table for x. And the component of coin, 2 outcomes, head and tail, or H and T. That's for coin. For coin, the component H and T. While dice, the component 6 outcomes, 1, 2, 6, 1, 1, 2, 3, 4, 5, 6. I would like to start with the random variable x. The random variable x, if the coin show tail or if the coin show t, it means based on this information that equal x equal 2 times dice score. Means dice score 1, 2, 3, 4, 5, 6. It means 2, 4, 6, 8, 10, and 12. And if the coin show the head based on this information, the dice score, this is if the coin show tail. The second condition is if the coin shows head, it means the dice score is dice score 1, x equal 0, 2, x equal 2, 3, x equal 0, and if 4, x equal 4, and 5, x equal 0, and 6, x equal 6, according to this information. Right. Hold on first. The total possible x values from these cases that x equal 2 equal 4 equal 0 equals 0 0 2 4 6 8 10 and 12. Now we're going to calculating the probabilities for each value of x. I will using this table. x, after that x 0, 2, 4, okay, 6, 8, 10, and 12. And after that, uh, probability, okay, the probability and source, the source to get the probability, right? If 0, the source is coin, hat, and dice, 1, 3, and 5. And the probability is 1/2 times 3 over 6 equal 3 over 12. Now, if x equal to the source is hat and 2 or tail and 1. So the probability is 1/2 times 1 over 6 plus 1/2 times 1 over 6 equal 2 over 12. If x equals 4, the source are hat and 4 or tail and 2. And the probability 1/2 times 1 over 6 plus 1/2 times 1 over 6 equals 2 over 12. And if x equals 6, the source is hat and 6 or tail and 3. And the probability 1/2 times 1 over 6, 1/2 times 1 over 6, 2 over 12. And if x equal 8, the source is t and 4. So this is 1/2 times 1 over 6, 1 over 12. And if x equals 10, the source is tail and 5. And the probability 1/2 times 1 over 6, it is 1 over 12. And if x equals 12, the source is t, the tail and 6, and the probability 1/2 times 1 over 6 equal 1 over 12. So this is the table. We can create a straight line here and straight line here, make table like this. Okay, find variance x. Okay, to find variance x, I would like to create table, but the variance x formula, expectation x squared minus e x squared, or for expectation, expectation e, for expectation x squared, this is x squared times probability x minus this is x times probability x, this. So if x 0, 2, 4, 6, 8, 10, 12. So the probability x based on part A, this is 3 over 12, is 2 over 12 is 4, 2 over 12 is 6, 2 over 12, 8 is 1 over 12, 10, 1 over 12, 12, 1 over 12 also. Now this one, x squared times px, x times px first. For x times px, 0 times This number is 0. Multiply is 4 over 12. 8 over 12. This is 12 over 12. This is 8 over 12. 10 over 12. And this is 12 over 12. And if you calculate sigma of x, px is 54 over 12. Now it's what? X squared. X squared times px. 0. This is 8 over 12. 32 over 12. 72 over 12. 64 over 12. 100 over 12. 144 over 12. And if you calculate sigma of x squared px is 420 over 12. So the variance x equal 420 over 12 divided by 54 over 12 squared. This is 35, and this is 20 over 20.25. And the result is 14.75. This is variance x. Number 4, the height in meters of white pine trees are normally distributed with mean 19.8 and standard deviation 2.4. In a certain forest, there are 450 white pine trees. How many of these trees would you expect to have height less than 18.2 meters? The first step, we need to convert to standard normal z-score with z formula equal x minus mu over standard deviation. So it's going to be 18.2 minus 19.8 over standard deviation 2.4 based on this information. And if you calculate, the result is minus 0.6667. And then after that, using standard normal table or calculator to determine this probability, z less than minus 0.6667 or 1 minus the probability z less than 0.6667. So it's going to be 1 minus 0. On table or calculator, you can gain this number 0.2523. So, and after that, we need to multiply by total number of trees. This number multiplied by the total number of trees becomes the expected number this number 0.2523 multiplied by this number 450 total number of trees 450, and the result is 113.535, round off 113.5. The height in meters of red pine trees are normally distributed with mean 23.4 and standard deviations sigma. It is known that 26% of red pine trees have height greater than 25.5 meters. Find the value of sigma of standard deviation. We're going to find the standard deviation. First, convert the probability to a z-score. The probability x greater than 25.5, 0.26. So the probability x less than 25.5, 1 minus this number, 0.26, 0.74. Look up the z-value corresponding to 0.74 in the standard normal distribution table. So the probability z less than z, lowercase z, is 0.74. On the table, z equals 0.642. Right, so now we're going to using the z-score formula. For the z-score formula, z equal x minus mu over sigma. Or if we are going to find the standard deviation or sigma, we can rearrange this formula. Becomes x minus mu divided by z, or x 25.5 minus 23.4 divided by this number 0.642, and you can get this number 3.271, okay, or 3.27. This. Number 5. In a class of 21 students, there are 10 violinists, 6 guitarists, and 5 pianists. A group of 7 is to be chosen from the 21 students. The group will consist of 4 violinists, 2 guitarists, and 1 pianist. In how many ways can the group of 7 be chosen? Right. 4 violinists from 10. It means the combination 10, 4. It is 210. 2 guitarists from 6. So the combination 6. 2, it is 15. And then 1 pianist from 5. So the combination 5, 1, it is 5. The total number of ways to choosing is 210 times 15, 5. 15,750. So, next question. On another occasion, a group of 5 will be chosen from the 21 students. The group must contain at least 2 violinists, at least 1 guitarist, and most 1 pianist. In how many ways can the group of 5 okay, be chosen? Right. So I would like to create a table for the scenario. So the column for scenario, after that the column for a possible valid combination, and the combination violinist, Gatories, and Pioneers. After that, the combination, we're going to find combination, okay, and after that, result here, right? First, uh, four violinists, one, two, three, four, and one guitarist. So it means four violinists, one guitarist, and zero violinists. So the combination becomes combination 10. 4 times the combination of 6, 1 times the combination 5, 0, because it is 0, 1, and 4. And if you calculate the result is 1,260. The second, three three violinists and two guitarists. So it becomes 3, 2, 0. The combination, 10, 3 times the combination of 6, 2 times the combination is 5, 0. So the result 1,800. And next, two violinists and three guitarists. 2, 3, 0. The combination 10, 2 times the combination 6, 3 times the combinations 5, 0. So this is 3,600. And three violinists, one guitarist, one pianist. 3, 1, 1. Combination 10, 3, the combination 6, 1, the combination 5, 1. And the result is 900. And after that, two violinists, two guitarists, and one pianist. 2, 2, 1. Combination 10, 2 times the combination of 6, 2, and the combination 5, 1. And if you calculate, the result is 3,375. Now, the accumulation, calculate 10,935. This is the result. 6. Teams of 15 runners took part in a charity run last Saturday. The times taken in minutes to complete the course by the runners from the Falcons and the runners from the Kites are shown in this table. Draw a back-to-back stem and leaf diagram to represent this information with the Falcons on the left-hand side. And if you create the stem and leaf diagram, I would like to show you this. Okay, that this side for Falcons, and then this side for Kites. Right. After that, uh, find the smallest data, Falcons and Kites. If you evaluate this data, you can find that the smallest data for Kites is 32, 32 like this, and the smallest data for Falcons is 38. And after that, after 38, 39 here. And the next data after that for on kites 40, double 40, 1, and double 40, so this one, okay, 40, 40 also. After that, 45, 47, 48. And on Falcons, it's 42, 44, 46, and 48. After 40, this is 50 for Falcons, 51, 52, 56, 58, and 59. While for kites, 52, 54, 58, 59, 59, double 59. After that, 60, 60 for kites. After 60, 61, 63, 65. And for falcons, 64 and 69. After 60, 76 only for falcons. There are not 70 on kites without 70s. So this is the stem and leaf diagram, okay, data in stem and leaf diagram. Let's continue. Find the median and the interquartile range of the times for the falcons. Right, so we need to find the median of falcons. If you evaluate this data, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7. So this is the median or second quartile. While for the third quartile, this is the third quartile falcons. And after that, this is the first quartile, right? So the median, okay, median, 51, and then the third quartile, 59, and the first quartile, 44. So interquartile range equal 59 minus 44, and it is 15. This is the interquartile range. Let's continue. The X and Y denote the times in minutes of a runner from the falcons and a runner from the kites respectively. It is given that sigma x equals 792, sigma x squared equals 40,504, sigma y 783, sigma y squared equals 40,223. Find the mean and the standard deviations of the times taken by all 30 runners. So it means n equal 30 from the two teams. Right. Variance formula equals sigma x squared plus sigma y squared over n minus mean. But we are going to find mean first. Wait, I'm going to write it here. Mean or mu equals sigma x plus sigma y divided by n. It is 792 plus 783 divided by 30, and the result is 52.5. So this is mean or mu. Now we're going to calculate variance. So based on this information, it is 43,504 plus 42,223 divided by 30 minus, this is square actually, minus this number 52.5 squared. And if you calculate variance, if you calculate is 101.32666. So after that, we can determine the standard deviation. Square root of variance 666, and the result is 10.0666 out of 10.1. This is the standard deviation. Number 7, in a game, players attempt to score a goal by kicking a ball into a net. The probability that Leno scores a goal is 0.4 on any attempt, independently of all others' attempts. The random variable x denotes the number of attempts that it takes Leno to score a goal. Find the probability x equal 5. This question is a geometric distribution problems. And the geometric distribution formula is the probability x equal k equal 1 minus p is probability, or k minus 1 times p. So sometimes we can writing this as q, or p times q power q, k minus 1. Now, if k equal 5 based on this information, so we can find p x 5, x equal 5. This is 1 minus 0.4 power 5 minus 1 times 0.4, because the probability is 0.4 based on this information. And if you calculate, the result is this is 0.6 or 4 times 0.4, and the result is 0.05184. Next question, B. Find the probability x greater than or equal 3, less than or equal 7. This probability equal probability x equal 3 plus probability x equal 4, probability x equal 5, probability x equal 6, and the probability x equal 7, because from 3 to 7. Now we're going to find one by one. The probability x equal 3 is 0.6 squared based on the previous information of 4. It is 0.144. And the probability x equal 4, it is 0.6 cubed times 0.4. This is 0.0864. Probability x equal 5. That is one. On the previous, this one. 0.05184. After that, probability x equals 6. It is 0.6 or 5 times 0.4, 0.031104. Scroll down. And the probability x equals 7 equal 0.6 power 6 times 0.4. It is 0.0186624. Now, the probability x, the probability x greater than or equal 3, less than or equal 7, accumulations of this number 0.144 plus 0.0864, 0.05184 plus 0.031104, 0.01866624, and if you calculate, the result is 0.331996 or 0.332. Next question. C. Find the probability that Leno scores his second goal on or before his fifth attempt. The formula for the negative binomial distribution we can writing as the probability secondary success on attempt K. Formula A is the combination K minus 1 and 1 times P squared, 1 minus P to the power K minus 2. Now we're going to find one by one, starting from K, for K equal 2. For K equal 2, this is the second goal on the second attempt. Okay, so the probability x equal to combination 1, 1, because 2 minus 1, 2 minus 1, 1. And after that, the probability is 0.4 squared, 1 minus 0.4, 0.6 power 0. And if you calculate, the result is 0.16. And for K equal 3, for K equal 3, this is the second goal on the third attempt. This one is the second attempt. This is the third on the third attempt. So for the probability x equal 3 is a combination 3 minus 1, 2, 1, 0.4 squared times 0.61, and if you calculate the result, 0.192. Next, for K equal 4. For K equal 4, this is the second goal on the fourth attempt. If this for K equal 3, this is the second goal on the third attempt. And for K equal 4, this is the second goal on the fourth attempt. So the probability x equal 4, combination 3, 1, 0.4 squared times 0.6 squared. And if you compute, this is 0.1728. Next, for K equal 5. For K equal 5, this is the second goal on the fifth attempt. So probability x equal 5, combination 4, 1, 0.4 squared, 0.6 cubed. And if you compute, this is 0.13824. Now we're going to calculate the probability, the second goal on or before the fifth attempt. Okay, what am I saying here? 0.16 plus 0.192, 0.1728, 0.13824, and the result is 0.66304 or 0.663. So, next question. Leno has 75 attempts to score a goal. Use a suitable approximation to find the probability that Leno scores more than 28 goals but fewer than 35 goals. More than 28, but fewer than 35. Right. For a binomial distribution, uh, binomial distribution B and comma P and n comma probability, which is n is 75. So this is the binomial distribution. This is 75, and the probability is 0.4. Okay. The standard deviations we can find square root n times p times 1 minus p equal square root 75 times 0.4 times 0.6. This is square root 18. And if you calculate this, it's 4.24. So this is the standard deviation. Now, we will approximate the binomial distribution becomes a normal distribution. From the binomial distribution becomes the normal distribution. The normal distribution 30, this is mu, and 4.24 squared. This is variance per square. Yeah, mu and variance. So the normal distribution like the mu, comma, variance, like this. All right. Now we want to find the probability 20 x greater than or equal 28, less than or equal 34.5. This is 28.5. Okay. I'm gonna fix x greater than or equal 28.5, less than or equal 34.5. We're gonna find this probability. Okay. The first step, we need to standardize the normal distribution. To standardize normal distribution, we need to using this formula z equal x minus mu over the standard deviation. So for x equal 28.5, okay, z1 equal 28.5 minus 30 divided by 4.24. And if you calculate, this is minus 0.354. Next, for x equal 34.5, the second z equal 34.5 minus 30 divided by 4.24 equal 1.061. Now, we can using a standard normal table or calculator to find the probabilities corresponding to the z-score. Okay, so for z equal this number, okay, for z1 equal minus 0.354. The cumulative probability, the cumulative probability is approximately to 0.361. And for the second C, this number, 1.061, the cumulative probability is approximately 0.855. So after that, we can calculate the probability. The probability that Leno scores more than 28 goals but fewer than 35 goals, x greater than or equal 28.5, less than or equal 34.5, is the probability z less than 1.061 minus the probability z less than or equal 0.354, becomes 0.855 minus 0.361, and the result is 0.494. This is the result.